Question number 4. In this question, there are multiple concepts. Newton's laws of motion. In this question, multiple concepts are there. Newton's laws of motion, plus relation between driving force and power, driving force and power relation, that is P is equal to F over V. Sorry, P is equal to F into V. This relation will be used here, and inclined plane motion concept. These are three concepts are lying in this question. So, question statement is: a lorry of mass 15,000 kg moves in a straight line road. Straight road. A lorry of mass 15,000 kg moves on a straight horizontal road in the direction from A to B. It passes A and B with speed 20 meter per second and 25 meter per second respectively. The power of the lorry, the power of the lorry's engine is constant, and there is a constant resistance to the motion of the magnitude 6000 Newton. This is the resistance. The acceleration of the lorry at B is 0.5 times the acceleration of the lorry at A. Part A of this question is: show that the power of the lorry's engine is 200 kilowatt, and hence find the acceleration of the lorry when it is traveling at 20 meters per second. First, we make a simple diagram to understand it more. Horizontal road. This is lorry. This point A and this point is B. This point is A and this point is B point. At point A, the speed is 20 meter per second. We are representing it with U. At B, the speed is 25 meter per second. Driving force moving on this side. The side is rightward. The driving force will be P over V because power is involved here. So driving force will be power over uh, speed. Using this relation, we know that power is equal to uh, F into V. So from here, driving force will be P over V. So this is the driving force, and the resistance force is 6000 Newton. So we are representing here this force is opposing force. F is equal to 6000 Newton, and mass of the lorry is given, that is 15,000 kg, and another relation is given between the acceleration of the lorry at point A and B. It is given that acceleration of the lorry at B is 0.5 times the acceleration of the lorry at A. This is a relation given. A B. Let A B denotes the acceleration at B is equal to 0.5 acceleration at A. This is given in the question. And now we will use here the Newton's laws of motion. Second, Newton's second law of motion. Now we will find two equations at first at A, at point A. equation will be P over V driving force, P over V at point A, P over VA minus opposing force 6000 Newton is equal to MA. M is mass of the lorry is 15,000. A mean acceleration at A. Let this is equation number one for reference. Now in the same way at point A B equation will be at point A at point B P over V speed at B. This is the driving force minus this 6000 opposing force is equal to MA. M is 15,000 and acceleration at B is A B. Let this is equation 2. Now we will use this relation between the acceleration of the lorry at B and the acceleration of lorry at A. In place of AB, we can put 0.5A, 0.5A here. So this equation will become P over VB minus 6000 is equal to 15,000 0.5 acceleration at A. We have to find the acceleration at A because it is required. Show that the power of the car engine is 200 kilowatt and hence find the acceleration of the lorry when it is traveling at 20 meter per second. So speed 20 meter per second is clearly at point A. So we have to find the acceleration at A. So we converted this AB into AA. So now we will simplify it from equation number 1. Now from equation number 1, this is equation number 1, P over 20 because speed is 20 at A, P over 20 minus 6000 is equal to 15,000 acceleration at A, and from equation number 2, P over 25 minus 6000 is equal to 7500. A at A multiplying 15,000 by 0.5 we get 7508. Now we will solve these two equations. Now we are subtracting these two equations. Sign change, cancel out. Finally we get P over 20 minus P over 25 is equal to 7500 AA. From here we can uh, make the subject of A. From here we can write this equation in this form. P over 75 0000. Now we will use this relation in equation A. In place of A, we can put P over 75 0000. From equation number A, from equation number A, 1, we can write P over, we are putting this value of A in equation number 1, we get P over 20 minus 6000 is equal to 15,000 into P over 75,000. Now we can find here from here the value of P simplifying P over 20 minus 6000 is equal to P over 50. From here we can easily find the value of P. From this equation you can simplify. From here we can find the value of P, that is equal to 2, there are 5 zeros. This is watt. Unit is the unit of power. Power is watt. But we have to show that power is 200 kilowatt. So dividing by 1000, we get finally P is equal to 2000, 200 kilowatt. This is the answer we have shown. Now also we have to find the value of acceleration at A. So this is the relation between acceleration at A and power. So putting the value of this power in this equation, we get the acceleration of the lorry at A. So from here, acceleration at A will be from this equation by putting the value of this P, we get acceleration at A 2000, sorry, 2 0 0 0 0 and 0 over 75 00 00. Finally, we get the value of acceleration correct to three significant figures 0.267 meter per second square. This is the answer. These are two answers, 200 kilowatt and 0.267 meter per second square. Now, next part of this question is the lorry begins to ascend a straight hill incline at 1 degree to the horizontal. It is given that the power of the lorry engine and the resistance force do not change. Find the steady speed up the hill that the lorry could maintain. So this question. In this question, we will use the concept of inclined plane motion. Steady speed means acceleration zero. So acceleration is zero. Now we will make an inclined plane. This is inclined plane. This is horizontal road. Then moving on inclined plane. This is an inclined plane. This is lorry. Now again the forces. We will mention the forces. Driving force we know P over V, and the resistance force is 6,000 Newton, because uh, driving force Power and resistance remains same, but another force, this is inclined at 1 degree, this angle is 1 degree. Now another force acting on this lorry is the weight of this lorry acting vertically downward, mg. Now we will resolve this weight in two components, one along the inclined plane and other is perpendicular to the inclined plane. These are the components. These are the components. This angle is 1 degree. These components are mg cos 1 degree, mg sin 1 degree. Now we use here Newton's laws, Newton's second law of motion. F is equal to ma. Net force is P over V minus resistance force 6000 minus component of the weight acting in opposite direction. This is the component of weight which is acting in the opposite direction of the motion of the lorry. Mg sin 1 degree is equal to ma. Since acceleration is a, so on the right hand side there is 0. Now power is same as in the first A part. Power is 200 kilowatt, but we will write here the value of power for calculation in standard unit, that is watt. 2000. There are 5 zeros over V we have to find minus 6000 minus mg sin 1 degree. M is 15,000, G is 10 sin 1 degree is equal to 0. Further calculation, minus 6000 minus 261, by using calculator the value of this term will be 261.786 is equal to 0. So 200,000 200,000 over V minus 8617.86 is equal to 0. From here we can find the value of V will be equal to 23.2 meter per second. Could have two three significant figures. This is the answer. 23.2 meter per second. This is the speed.